Hello and good day to you. Thank you for reviewing the chapter 5 of our topic in PAT204, construction material. So, in this chapter, we're going to learn the steel material that is used for construction. So, our topic learning outcome for this chapter is the student should be able to explain the steel manufacturing, heat treatment of steel, steel alloys, structural steel and reinforcing steel. So you should be able to explain how the steel being produced and what is heat treatment, why the need for heat treatment for steel, and to be able to explain what is steel alloys, structural steel and reinforcing steel. Next, you should also be able to analyze the stress strain curve and modulus of elasticity, which is very related to steel products, and also explain the advantage and disadvantages of steel as a structural material as compared to other structural materials such as concrete and wood. So the first topic in the outcome we are going to cover is explain the steel manufacturing. So steel starts from iron ore, which is found in large quantities on earth crust. So basically, the iron ore is mined from the earth, being mined and need to be refined to produce steel. So pure iron is ductile and soft, but not strong enough for structural purposes. So it is a ductile material and soft. It has good magnetic properties, but oxidizes, which it rusts easily and does not resist attack by acids and some chemicals. For commercial purposes, iron must have alloying elements added to improve its characteristics. Typical commercial iron product is called pig iron. Pig iron is the base material to produce various types of iron and steel. So it is the base material before it being mixed with other alloying element to produce a strong steel. It is the main ingredient in cast iron, steel, stainless steel, and iron alloys. So how do we produce iron from iron ore? So iron ore is converted into pig iron in blast furnace. This is the equipment, the factory, which is blast furnace. Blast furnace used to produce iron from iron ore by method of smelting and reduction. So smelting is the process of heating the ore, allow iron to be separated from impurities with which it is chemically or physically mixed. So from the raw material of iron ore with other impurities need to be heated, which is called smelting, and then reduction. Reduction is the process that separates iron from oxygen with which it is chemically mixed. So reduction is you want to remove oxygen from iron. Smelting is the process of heating the iron. To both objectives of the method is to remove the impurities, but smelting is to remove impurities by method of heating. Reduction is to remove oxygen. So next we want to learn what is a blast furnace that is being used to refine iron ore. Blast furnace is a cylindrical shaft of around 45 to 61 meter height and 9.2 meter wide, which is in diameter at the base. Usually its diameter at the top is smaller. It is lined with refractory brick made of materials such as magnesia that withstand temperatures almost 3000 Fahrenheit or 1662 Celsius degrees. So it is lined, the lining around the perimeter of the shaft is made of refractory brick, usually magnesia. They can withstand the high temperature during the process. So materials added to the blast furnace contains the ore, and then you also need to add fuels and flux. Fuels is usually is coal or oil or natural gas. Some uses coke, which is produced from coal, which not only provides heat to melt ore but also helps separate iron from its oxide. So basically, the coke doesn't only heat up the metal ore, melt the ore, iron ore, but also helps in the reduction process, which separate iron from oxygen. And also you need to add flux. Flux is added to molten ore to combine with impurities to form slag and floats on top of the molten material flux. Molten material. So flux is a mineral that you add to combine with the impurities, so that the impurities will be separated from iron ore to produce a pure ore. And typically the flux is used from limestone or dolomite, which is both are minerals. So the process of blast furnace, first you load the ore, fuel and flux. Fuel can be hot coke and flux can be limestone, dolomite. So all these three materials are loaded at the top. So a blast of hot air is injected at the bottom. So as the air works its way up through the charge, oxygen in the hot air combines with the hot coke, which causes combustion that produce necessary heat to melt the ore. As the gases from the combustion pass through the heated ore, a chemical reaction occurs that frees the iron from its oxides. Then the gases are removed from top of the furnace and pass through cleaners which retain the dust. So the clean hot air passes through heat exchangers that in turn heat new incoming air. So it's a continuous process that heated the hot air heat the fuel. The fuel causes combusted and then heated up the ore, and then ore a chemical reaction occurs due to the heat, and then the impurities combine with the flux, and then the flux is floated will float on at the top, which you can separate from the pure iron. So the molten pig iron, which is the pure iron, settles to the bottom of a furnace and is tapped off every few hours. So you collect every few hours the pure pig iron. So the molten pig iron tapped at this point is impure and brittle, containing 4 to 5% of carbon. High carbon content causes pig iron to be brittle. So may contain some impurities. So if it contains these impurities, the pig iron must undergo additional processing in a steel making furnace to reduce the carbon content. So the impurities, flux and oxygen combine to form a slag on top of the molten iron, which is periodically tapped off. The slag is used as an aggregate for concrete, looses fill and road surface. This is the byproduct which the mineral combined with the impurities that is called slag, which is often used as aggregate for concrete or admixture in concrete, or as a partial replacement of cement in concrete, as a looses fill to when you backfill the working table for road, and also some for road surface. So the molten pig iron is moved to furnaces called mixers to equalize the chemical composition and kept it at a liquid state until used. Sometimes molten iron is molded into ingots and allowed to cool. So two form of steel, molten pig iron, either it is a molten iron or molded into ingots. So this is a figure of a blast furnace. You can see at the top here is a smaller diameter, and the bottom is a slightly larger diameter. So you load the iron ore in the flux in the coke as a fuel is loaded from the top. So hot air is pumped from the bottom as hot gases move through the iron ore. It heats up the ore and then causes combustion in coke, and the coke burns, and the iron and slag melt. So the heated carbon dissolves in the iron, and then the slag is formed, and the molten iron will be at the bottom. So the slag will float on top of the molten iron. So periodically, molten iron will be tapped off, and slag can also be tapped off to remove. So these hot gases that moves upward towards the top, being recycled back to reheat the air, and then the cycle continues until all of the mixes the ore, flux and coke has been used, and it can be refilled from the top. So this process is a continuous process.